Hey everyone, it's Alejandro from Tutoring by Alejandro. So today we're going to master factoring quadratic equations, one of the fastest solving methods. If you recall, in the last video, I taught you guys how to use the quadratic formula, but sometimes we can apply factoring, which is a bit quicker. And so at the end, I'll show you exactly when to use factoring versus the quadratic formula, with examples of all three cases, when we have some nice integer roots, irrational roots, and no real roots. So just to recap, again, the quadratic equation looks like this. Ax squared plus bx plus c equals 0, right? So factoring just means rewriting it as two binomials multiplied together. For example, you have x plus, let's call it m, right? Times x plus n equals 0, right? Binomial just means two terms, right? So this is a binomial, okay? Right? So when you factor, you're rewriting that quadratic equation, again, as two binomials multiplied together. Once it's in this form, solving is easy. You basically just set each factor equal to 0, and you find x. Okay? So the key idea is this. We need two numbers that multiply to give c, the constant, right? This value here. And that add to give us b, the coefficient of x to the first power, right? So again, those two numbers have to multiply to c and add up to b. So that's the golden rule of factoring, okay? So let's start with some easy examples. Okay, so the first one is you have x squared plus 7x plus 12 equals 0. So again, we need two numbers that multiply to 12 and add up to 7, okay? So I can think of 3 and 4, right? So we can factor this quadratic equation into x plus 3, right, times x plus 4 equals 0, right? So to get our solutions, recall, we're going to set each of those binomials equal to 0. So we should be able to get two solutions. Not always, remember. Sometimes you will get one. But okay, so let's see. X plus 3 equals 0. And let's solve for x, right? So we have to get rid of the 3 on the left. The 3 is adding, right? So we're just going to subtract 3 on both sides. And that will give us x equals -3, okay? Now on the other side, for the other binomial, we have x plus 4 equals 0. And similarly, we're going to subtract 4 on both sides, right, to isolate the x. And that'll give us x equals -4. So those are our two solutions. So again, we could use the quadratic formula to solve this, but as you can see, factoring in this case is way quicker. Okay? Okay, so now we have x squared minus 16 equals 0. Okay, so if you remember the structure of the quadratic equation, we have ax squared plus bx plus c equals 0, right? So in this case, we don't have an x term, right? So our b is 0 in this case. Our c is equal to -16, right? Um, so this is actually a special case, which is called a difference of squares, okay? So a difference of squares is when you have um, two terms, the first term squared minus the second term squared equals to 0. And the way you factor that is a minus b times a plus b equals 0, right? You just take the square root of each term, right? So in this case, you would have x, right? Because it's the square root of x squared, minus 4, because it's the square root of 16. And then you're just going to have times x plus 4, and that equals to 0, right? And solving gives you x equals plus 4 from this one, and x equals -4 from this one, right? Now, if I didn't know the difference of squares, you could solve it using regular factoring, right? So we identified that b is equal to 0, right? So I could technically rewrite this as x squared plus 0 times x minus 16 equals 0, right? And we're looking for two numbers that when multiplied give you negative 16, and when added up give you 0. So again, those two numbers will be negative 4 and positive 4, right? Negative 4 times positive 4 will give you negative 16. And if you add them up, negative 4 plus 4 will equal 0. Okay? All right. So these kinds of problems are where factoring shines. It's much quicker than using the quadratic formula. All right. So let's move on to some tougher exercises. Okay. Okay. So now let's try some harder exercises where the coefficient in front of the x squared isn't 1, right? In this case, we have 2x squared plus 7x plus 3 equals 0. Okay. So these are handled a little bit differently. So if you recall the quadratic equation, again, it's ax squared plus bx plus c equals 0, right? So our 2 is a in this case, 7 is b, and 3 plus 3 is c, okay? So we're going to multiply a and c together, right? A times c. That is going to be 2 times 3 equals 6, okay? So we're going to find two numbers that multiply to give us 6, right? And add up to 7, okay? And those numbers are 6 and 1, okay? So those numbers, again, they have to multiply to the value of a times c, okay? But they have to add up to the value of b, or 7, right? Okay, so we know those values are 6 and 1. Okay, so 6 and 1 because 6 times 1 equals 6, and 6 plus 1 equals 7. Okay, right? There we go. So what we're going to do is we're going to rewrite the quadratic equation that we have by breaking up the middle term. Okay, so like this way, okay? X 2x squared plus, instead of 7x, I'm going to write 6x plus x, okay? And then the c just is remains the same, okay? Okay, so now I'm going to group the terms, okay, in two separate groups. I'm going to take the first two terms, okay? So I'm going to take the 2x squared and the 6x, okay? We're going to group them together. So 2x squared plus 6x, that goes in one group. And then the rest in my other group. So my other group is x plus 3, okay, equals 0. Okay, now we're going to use common factor on the first term, on the first parentheses, right? And if you look closely, we can see that we have a common factor of 2x, okay? Why? Because I can divide both of those terms by 2x without any remainder, okay? So Um, let me do it real quick on the right. So I have 2x squared divided by 2x, right? The 2's cancel out, right? And then we have x squared divided by x. If you recall the rules of exponents, if you have the same base and they're dividing, you subtract the exponents, right? So that gives you x to the 2 minus 1, right? Or just simply x, right? Okay, now that's plus, and then we're going to divide 6x by 2x. Okay, the x's cancel out, and you're left with 6 divided by 2, which is 3. Okay, okay, let's rewrite the second one. Okay, that's equal to 0. Great. And now we have another common factor that we can apply, right? we have x plus 3 in the first term and x plus 3 in the second term, right? So we're going to take common factor x plus 3, right? And we're going to divide each term by that. So again, the first term is 2x times x plus 3 divided by x plus 3. So when you divide that, the x plus 3's cancel out, right? And you're left with 2x, right? Great. Now for the second term, we have x plus 3 divided by x plus 3, right? So we have the same value on the top and the bottom, right? So that just evaluates to 1, right? So that's 2x plus 1, right? That's equal to 0. Great. Okay, we're almost there. Now, to actually get our solutions, we have to set each binomial equal to 0. So for the first one, it's pretty easy, right? You have x plus 3 equals 0. Okay, the 3 is adding, so we're going to subtract 3 on both sides, right? That just gives us x equals negative 3. Okay, so that's our first solution. Now, our second solution is 2x plus 1 equals 0. Okay, we're going to start, remember, we start by getting rid of whatever's farthest away from the variable we're trying to isolate. In this case, the positive 1. So we're going to subtract 1 on both sides. Okay, so that gives us 2x. Plus 1 minus 1 just gives us 0. I'm not going to write it. And then on the other side, I have negative 1, right? Now we'll get rid of the 2, right, on the left by dividing by 2 on both sides, right? Because the 2 is multiplying. So divide by 2, divide by 2. The 2's cancel out on the left. And my other solution is x equals negative 1 half. So those are my two solutions for that one. Okay, let's do another example. Now we have 3x squared minus 2x minus 5 equals 0. So again, this is my A, this is my B, and this is my C. We're going to multiply A times C, which means I'm multiplying 3 times negative 5. And this comes out to negative 15, right? So remember, we need two numbers that when you multiply them, they evaluate to negative 15. And when you add them up, they add up to negative 2, right? The B term. Okay. So two numbers that can do that are negative 5 and positive 3, right? Negative 5 and positive 3, when you multiply them, they come out to negative 15. And if you add them up, negative 5 plus 3, this comes out to negative 2, right? Because you subtract them because they are opposite signs, and it adopts the sign of the greater value, right? 5 has a greater value than 3, so your answer is going to be negative. Okay. All right, so those are our two numbers. Great. So what we're going to do is we're going to rewrite the quadratic equation. Okay, so let's rewrite it as 3x squared. Then we have minus 5x, okay, plus 3x, okay, minus 5 equals 0. Great. Now let's group them in two different groups, right? We're going to have 3x squared minus 5x, right? And that's our first one. And then you have 3x minus 5, okay? All of that equal to 0. Okay, great. Now we're going to have to implement common factor, all right? I've never actually made a video on common factor, but I feel like I have at this point. We've used it plenty of times. So for the first binomial, there is no common factor in terms of the coefficients, right? But we do have an x term in both 3x squared and negative 5x. So we'll use common factor x. Okay, divide each term by x. So right here on the left, 3x squared divided by x just gives us 3x, right? And then we have negative 5x divided by x. The x's cancel out, and you're left with negative 5, right? Okay. right? Now for the other one, um, well, for the other one, we don't really have any common factor per se. Well, we kind of do, right? It's 1, right? 1 is our common factor in this case. There's nothing else. Okay. And now we have a new common factor, right? Which is what we were trying to do from the beginning, like in the last exercise. Our common factor now is 3x minus 5. So we're going to use that as our common factor, 3x minus 5, right? And we're going to divide each term by that. So again, illustrating the first term, x times 3x minus 5 divided by 3x minus 5. They cancel out, right? And we're left with x, right? And now we have, let's call it 1 times 3x minus 5 divided by 3x minus 5, right? These cancel out, and we are just left with plus 1, right? That equals 0. Okay, great. Now for the last step, remember, we set each binomial equal to 0 and solve for x. So let's do the easy one first. X plus 1 equals 0. Subtract 1 on both sides, right? That gives us x equals -1. Great. Now for the other one. 3x minus 5 equals 0. Okay. So the 5 is subtracting. So we're going to add 5 on both sides, right? Okay. The 5's cancel out. And then we're left with 3x equals 5, right? Now the 3 is multiplying. So we're going to apply the opposite, right? Which is just dividing both sides. The 3's on the left cancel out, and we are left with x equals 5/3. Okay, so those are our two solutions, x equals -1 and x equals 5/3. So these take a few more steps because, you know, the coefficient of the x squared term is not 1, but factoring still works nicely, and I guarantee that it'll be quicker than the quadratic formula still. Okay, all right, moving on. Okay, so sometimes factoring won't work because the solutions aren't real numbers. That's when we use the quadratic formula. So at first glance, you see a very deceitful, very simple looking quadratic equation, right? You think it's simple. X squared plus x plus 1 equals 0, right? In this case, our a is 1, right? Our b is 1, and our c is 1, right? So if we were to follow, you know, what we've been doing, you need to find two numbers that when multiply, right, m times n, right, when multiplied give you c, which is 1, right, but when added also give you 1, right? Um, that's pretty hard to do, right? If you're using integer factors, I guarantee you won't be able to think of two numbers that fulfill those two conditions within 15 to 20 seconds. And as a rule of thumb, if you don't see any integer factors within 15 to 20 seconds, stop, right? Switch to the quadratic formula, which, you know, is a surefire way of solving these exercises. So even the previous ones, remember, you could have used the quadratic formula if you were stuck without knowing what to do. Takes a little longer, but it's a foolproof way of doing these exercises. So if you recall, you have x equals -b plus or minus square root of b squared minus 4 times a times c divided by 2 times a. Okay, if I plug in the values, I'm left with -1 plus or minus square root of b squared is just 1, right? 1 squared is 1, minus 4 times a, which is 1, times c, right? That's 1, divided by 2 times 1, right? If you evaluate the square root, it comes out to 1 minus 4, right? And 1 minus 4 is equal to -3. So if you remember from the last video, whenever the discriminant, which is this b squared minus 4ac term, is less than 0, okay, we say that there are no real solutions, right? Okay, so in terms of the SAT, I don't believe you're going to encounter imaginary numbers, right? So, but the quadratic formula was able to discover this, right? So it's very handy. Okay. Similarly, we have 2x squared plus 3x plus 7 equals 0. Again, if you try to factor, if you try to find two numbers to fulfill the conditions we laid out before, you won't be able to do that. But if you use the quadratic formula, right? And let's not even plug the whole thing in, right? Let's just calculate the discriminant. So our b is 3, positive 3. Our a is 2, right? And our c is 7, right? So we have b squared minus 4ac. So that's going to be 3 squared minus 4 times a, which is 2, times c, which is 7. This comes out to 9 minus 4 times 2 is 8, right? And 8 times 7, okay, right? 8 times 7 comes out to 56, right? And we already know that this value, right, since the 56 is negative and the 9 is positive, this value is less than 0. So there are no real solutions, okay? So again, rule of thumb, if you don't see integer factors within 15 to 20 seconds or so, stop and switch over to the quadratic formula, which always works, okay? So now we're going to move on to some exercises where there are real solutions, but factoring would overcomplicate things. Okay, all right, moving on. Okay, so here's an example where the quadratic formula gives real but irrational roots. Okay, so if you were to try factoring, remember our a in this case is 1, right? Our b is -2, and our c is -1. So we technically need two numbers that when multiplied give us -1, but when added will give us -2. Um, there are two numbers that can fulfill both conditions, but they're not integers, right? Um, and you could test it out by using the rule of thumb, right? Think about two numbers that can fulfill those two conditions, and you'll very, very likely spend more than 20 seconds doing that. All right, so let's move on to the quadratic formula. So we have x equals -b plus or minus square root of b squared minus 4 times a times c divided by 2a. Okay, plugging in the numbers gives us minus from the formula. Then you have -2, right? -2 plus or minus square root of b squared, which is -2 squared, minus 4 times a, which is just 1, right? And then times c, which is -1. All of that divided by 2 times a, which is just 1. Okay? Now we have a negative and the negative, right? This comes out to +2, right? Plus or minus square root of a negative value raised to an even exponent comes out to be positive, right? And then 2 squared is just 4. So this is going to be +4, right? And now for the second term, we have -4 times +1, which will just give us -4 again, right? And then you have -4 times -1. So you have a negative multiplied by a negative. And remember, when you multiply two numbers of the same sign, you're going to end up with a positive value. So that's going to be 4 times 1, right, equals 4, right? All of that divided by 2 times 1 equals 2, right? And I don't need to write the positive, right? Okay. And then we have square root of 8, positive 8, right? In this scenario, the discriminant, the b squared minus 4ac term is greater than 0. So there are real solutions, right? Okay. So if we simplify this, um, we're going to end up with, let's separate these into two fractions, right? Because I have just one value in the denominator, so I can rewrite this as 2 over 2 plus or minus square root of 8 divided by 2, right? And then I have my first solution, which is 2 divided by 2 is 1, right? 2 divided by 2 is 1, plus square root of 8 over 2, right? Okay. And then for my other term, my other solution, I have 1 minus square root of 8, okay, divided by 2. Okay, perfect. I'll leave you to simplify this even further if you wanted to, but this comes out to 1 plus square root of 2, and this one comes out to 1 minus square root of 2. Okay, so those are our two solutions here. As you can see, they're not integers, so factoring wouldn't really work here. So the quadratic formula is our foolproof way to solve these types of exercises. Okay, all right, moving on. Let's tackle a word problem. Okay, let's apply this to a real SAT style word problem. So we have a ball is thrown upward and its height in meters after t seconds is given by h equals negative 5t squared plus 10t plus 15. When does the ball hit the ground? Okay, it's very similar to the word problem we tackled in the previous video. So remember, the keywords here are the ball is hitting the ground. So that means h, being the height, will be equal to 0, okay? So let's write that quadratic equation as negative 5t squared plus 10t, right, plus 15 equal to 0, right? Instead of x's, we're using t's, right? It's pretty much the same way, right? We're solving it the same way. So here, um, so far, we have negative 5 as a, b being 10, right? And c being 15. But in some cases, we can simplify this further to make our lives easier in the long run, okay? So if you look closely, you can see that all three terms can be divided by negative 5, right? So let's do that. So if I divide, let's see, let's rewrite this. Okay, so let's divide every single term, right? When we divide on both sides, we have to do it to every single term. So dividing by negative 5, negative 5, negative 5, and negative 5 here, okay? So for the first term, we have that the negative 5's cancel out, so that gives us t squared, right? Now we have positive 10t divided by negative 5, right? So we divide the coefficients, so that's 10 divided by negative 5. So a positive divided by a negative will give us a negative, and then 10 divided by 5 is just 2. So that's 2 times t, right? Then we have another positive divided by a negative, right? So again, we're going to get a negative value, and then 15 divided by 5 is just 3, right? Okay, that equals, and then 0 divided by any number, right, except 0, is 0, right? So there we go. We still have a quadratic equation, but this time the a is now equal to 1, right? Making this much simpler. Okay, so If we factor this, meaning we're looking for two numbers that multiplied give us -3 and added give us -2, that's going to be, let's see, -3 and +1, right? -3 times +1 equals -3, and then -3 plus 1 will give us -2. So those work. Okay, so let's factor them. So we have t minus 3 as our first term, and then we have t plus 1, right? Set this equal to 0, all right? Now, to obtain our solutions, remember we're going to set each binomial equal to 0. I don't really need the parentheses anymore. So for the first term, it's t minus 3 equals 0. We're going to add 3 on both sides, right? And that means we end up with t equals +3, right? And now for the other one, we have t plus 1 equals 0. Okay, we're going to subtract 1 on both sides. So that gives us t is equal to -1, right? So those are our two solutions. But let's say this was multiple choice. And let's say they gave you both answers, right, as options. Let's say our A option was 3 and our B option was -1. Which one would you choose? So mathematically, there are two solutions, but we have to apply this to real life, right? Word problems model real life situations. And T, right, is time, right? It's given in seconds. So time cannot be negative, right? So that means I can eliminate this answer because it basically doesn't follow the laws of physics, right? It's not realistic. So our solution is t equals 3. The ball will hit the ground after 3 seconds. So in the previous video, I solved a very similar problem using the quadratic formula, right? Um, this one can also be solved using the quadratic formula, but if you compare the times, you'll notice that factoring saved us some time here, okay? So it came in handy here. So how do you decide which method to use? So remember, you're going to use factoring when the numbers are small and you can quickly see integers that multiply to the C term, right? And add up to B, right? You shouldn't spend more than 20 seconds thinking of those two numbers, okay? So you're going to use the quadratic formula when factoring doesn't work or when the roots are irrational or complex. So you're going to think of factoring as the shortcut and the quadratic formula as the guaranteed backup plan. Okay? So to recap, if you have some nice integers, factor. Some messy irrational roots, use the quadratic formula. No real solutions, again, use the formula. Both methods give the same answers, but factoring is faster when it works. Okay? So thanks for watching. If this was helpful, please give this video a like, subscribe for some more SAT math strategies. So thanks again, everyone. I'll see you in the next video. Okay, bye-bye.